So in this video, we'll be learning about the disk method to find the volume of a curve. So the formula is as follows. V stands for volume, is equal to the integration from a to b, pi r squared here is going to be a function, and I will explain that briefly right now. So let's imagine that we have a cylinder where we have the cylinder as a fixed radius. So r here is going to be fixed, right? Now what if we have a cylinder where the radius is changing? And now I'm sorry about my drawing, it's not the best. I'm trying my best here. This could be a cylinder, right, also? And here r is different at each point. So this is longer, this is more longer, and so on. So that is why we write r of x squared. And this volume is going to rotate against a line, x-axis, or could be y-axis even, and we will go over that shortly. So right now I'm going to write dx, and here the x is going to be between a and b, which are the two limits here. Also, another important thing that you would notice here is the formula for a circle is pi r squared, right? And here, what have we done? It is pi r squared, but we are integrating it since volume is the integration, or sorry, area. Actually, volume is the integration of area, basically. So what we're doing in this formula is we are integrating the formula of area for finding the volume. So now let's start with our first example, and this will be more clear to understand. Of y is equal to radical x is bounded by x is equal to 0, x is equal to 4, and the x-axis is revolved around about the x-axis, and we are supposed to find volume. So always, whenever you have a question like this, it is always best to visualize the area, or the volume. So the first step here is to draw the graph of y equals radical x and put these points in the x values and just visualize it, So here I'm going to draw the graph. It's going to be so I'm going to put 1 2 3 4. This is the point for 4. Now this is not accurate, but you can do this. This is going to be 1 and 2. See, since when we put x as 4, you're supposed to get y as 2, since the radical 4 is 2 and 1 is supposed to be 1. So this should be matching with this, but that does not really matter. We want to visualize this. Now this line is equal to radical x, and now we draw the line which is x equals 4, which is just a vertical line over here. And now what we're doing here is we are looking at the area of the shaded part, and we are revolving around the x-axis over here. And if we revolve this is gonna look like, okay, let me choose some of the color here, something like this. And we are to find the volume of this shape over here, and this is to indicate that the shape is a 3D shape. And here you will have infinite number of discs inside. So this is one disc, this is the second disc, and so on. So you have infinite number of discs inside, and this is why the method is called the disk method, since we are finding the area of the small disk inside infinitely through the integration. Now, to find the area of the small disk, we need the radius of each of these disks, right? So it's going to be, let me change the color again, something else here, let's choose blue. It's going to be from here to here. For this disk, it's going to be from the x-axis to this point over here, and so on. So what is this, the radius here? It is simply going to be the function, right? Y is equal to radical x. So here now let's write the integration. It's going to be from 0 to 4. So this was 4 and this is 0 over here. We're starting from 0, we're ending at 4. 0, 4. Now the formula is pi r squared now, and r here is going to be the radius. And what do we agree on for the radius? It is simply the function over here. Since every time we are going forward, the radius is simply radical x. So here we can replace it with radical x. The square root cancels out with the radical, I mean squared cancels out with the radical, and we are left with 0 to 4 pi x dx. And here we integrated according with dx. So x, so I'm going to take pi outside since it's a constant, and we have x 2 over 2, and the limits are from 0 to 4, and the answer would be 0 is going to be 0, so pi times 16 over 2 minus 0, since 0 over 2 is going to be 0, I'm going to ignore that. So simplified is going to be 8 pi. So the final answer is 8 pi. So let's do our second question now, question 2, which is we get the equation to be x squared plus y squared is equal to a squared is revolved around the x-axis. And now we need to find the volume. So the first thing that we notice is that we have an equation of 3 variables over here, and this is the standard equation for a circle, if you don't know that. And we first need to rewrite it in terms of y. So it's going to be y squared is equal to a squared minus x squared, and y is equal to radical a squared minus x squared plus minus. So here I'm going to graph the equation, and to graph a circle it's pretty simple. I will be making a short video or a video on how to graph a circle, but here what we do is, since we have 3 unknowns, we are going to substitute a in x. So try putting a in x is going to be y is equal to a, and that is how we get this point over here, which is a, this point over which is a, this point a, and this point a. Now we need to draw a circle here, and I know that my circle is not perfect, but just bear with it for now. And now we are revolving around the x-axis, so the area, or sorry, the volume that we are finding are these discs inside the circle. So let me do that and change the color again. This is one disc, this is the second disc, and the biggest disc will be in the center, and that's it. Oops. Yes, so this is it, and the radius of the circle is from 0 here to a point, which is r, and over here is going to be this radius, and here is going to be r. So now let's write the integration equation. So the integration from a, sorry, this is negative a by the way, and this is negative a, so negative a to a of the equation, the formula is pi r squared, and here our r is going to be the equation of line for y, which is over here. So I'm going to replace r squared with our equation over here, which is radical a squared minus x squared dx. Now the radical is going to cancel out with the square, and all we left here is a squared minus x squared, and I'm going to take the pi outside also. Now let's integrate this. So it's going to be a to the a squared times x. Since we are deriving in terms of x, we can treat here a squared as a constant. Let's say it's like 4. And how do we integrate 4? It's going to be 4x if it's dx, right? So here's the same thing. A is the constant here, and we add a x term in it, minus x3 over 3 from the limit from minus a to a. And now we can substitute x with now minus a and then a, and you will get the answer of, so here we are gonna substitute a with x first, so it's gonna be a squared into a, which is, I'm gonna simplify it right away, minus a cube, minus a cube over 3 minus, now open brackets, now we are gonna substitute with minus a, so here we are gonna get a minus a cube minus a cube over 3, and this is going to be plus then. So let me write it again. Did I make a mistake here? Now let's simplify this. So I'm going to distribute the minus sign over here, so it's going to become 2a3, and this minus sign is going to go here also, so it's going to become minus a cube over 3 over here, so minus 2a cube over 3. Now let's make it same denominators. So this was 2, so to change it to over 3, we can multiply the numerator by 3 and the denominator, which is 1, so times 3 times 3. Now we have the final answer of 4a cube over 3. So always first visualize by graphing the graph or the equation, and then check for which area or which volume are you solving for, and then apply the formula and you will get the answer. So our next question is a bit more challenging, as we are not revolving around x-axis, we are gonna revolve around the y equals 1, line y equals 1. So our question 3 is y is equal to radical x, and we have y is equal to 1, y x is equal to 4 is revolved around the, or let's just say y equals 1, and we need to find the volume. So here let's first graph this equation. So let's take any 3 or 2 points for x and y. So when x is 0, y is 0, when x is 1, y is 1, and when x is 4, y is 2. So 1, 2, 3, 4. This is a point, and 1, 2, boom, and then this one, and then this one. So since we're gonna need more space for this question, I just drew it with more space. Now let's draw the line which is y is equal to 1, which is just a horizontal line on the intersecting the y-axis, so it's just like this, and let's move it above. Now our last line which we need to draw is x is equal to 4, which is this vertical line right over here. So here, which volume or which space are we revolving, and which space here is bounded by all these lines over here? It is gonna be the area or the space over and shaded in the red area. Since we want the area between y equals radical x, y is equal to 1. Let me write the equation over here. Y is equal to 1 and x is equal to 4. And this is the area that we want. So this is why we always draw the graph first and visualize what area or what volume are we trying to find. And now if we revolve this around y is equal to 1, we are going to revolve it right over here, right? And basically this is what we are going to get. So now, as we have visualized the area or the volume that we are solving for, now let's start the integration. So what x are we going to start with? It's going to be from 1, since you know we're starting from this point all the way up to 4. So once again, we are starting from 1 here all the way to 4. So our limits or the range is going to be from 1 to 4. So it's going to be pi. And now I want you to focus very carefully. What is our radius over here? If I erase this red part, our radius is basically from here all the way here and so on, right? It is not starting from the x-axis, since we are revolving around y is equal to 1 and not y is equal to the x-axis. So if it was the x-axis, then yeah, we would take this entire radius, but here we are revolving around y is equal to 1, so that is our radius. So here I just drew the graph bigger, and I want you to visualize that this is the r, and here we know that the distance from the x-axis all the way here is the equation of line here, which is y is equal to radical x. So how would we find the smaller r over here, or let's call this the lowercase r, or the other way around actually. So capital, and this smaller one is this lowercase r. So how do we find the lowercase r over here? And here we know that r, the capital R, is equal to y, which is equal to radical x, right? And another thing that we know is that this line is equal to y is equal to 1. So what would this distance be? It would be 1, right? Pretty obvious. So how would we find the lowercase r over here? So let me draw it again. So this is r, capital R. This is the y is equal to 1. We know that this distance is r1, and we need to find is the lowercase r. So the way to do that is to, so here what the lowercase r will be equal is capital R minus 1. Since we are, actually let me draw it more clearly. Actually you can see it over here. The capital R is the entire distance. We know that this distance is 1. So if I draw it over here, this distance is 1, and we need to find the lowercase r over here. And simply we would just do subtraction. So we know that entire distance is capital R minus 1 will give you the lowercase r. Now if we substitute capital R with what we have for y is equal to radical x, so lowercase r will be equal to radical x minus 1, and that is the radius. So a very simple way of explaining this is, let's call this something like 5 centimeters, and you know that the distance from here to here is 2. So how would we find the distance from here to here? It's pretty simple, right? It's just 5 minus 2 to find this. So it's the same exact thing right here. But in our case, it's a variable. It's always changing. But here it's a constant. So that is why we use the variables over here, which is radical x minus 1. So now we have everything for the integration. So now let's write it down. So it's pi r squared, and r squared we found that it is radical x minus 1. So here is going to be radical x minus 1 squared dx, and now we just need to simplify this. So this will be equal to, so here we just simplify the brackets over here. So this is a squared minus 2ab plus b squared. So I'm going to take the pi outside here. So pi, and then integration from 1 to 4. This is going to be a squared, so x minus 2ab, so radical x, and then b is just 1, plus 1 dx. Now we integrate this, so it's going to become x2 over 2 minus 2. This is going to be x3 over 2 over 3 over 2, 4, 2 times 2, 4, and then plus x. Now take the limit from 1 to 4, and don't forget the pi outside. So the final answer you'll get is 7 over 6 pi. So let's move on to our next question, where we have to revolve around the y-axis. So question 4, and this is bounded by the y-axis. So here we will be integrating in terms of dy instead of dx, and the line is x is equal to 2 over y comma 1, and then from 1 to 4 revolved around around y-axis. So again, the first step is to draw, of course. So I'm gonna draw over here, and now I'm gonna take some points, let's say for x and y, so we can place them over here and draw. So let's take y as 2, so I'm gonna do actually y and then x. So when y is 2, x is gonna be 1. When y is 4, when y is 1, then x is gonna be 2. And the last point I'm going to take is when y is equal to 0.5, x is going to be 4. And actually here a better point would be y is equal to 4. So here x will be equal to half. So now let's plot it out. So here is the graph. It's not accurate, but I just drew it as best as I can. And here what we want to find is the area revolved around the y-axis, and it is from, also notice the interval is from y is equal to 1 to y is equal to 4. So we do have a horizontal line over here, which is y is equal to 1. Let me draw that out. And we want to also revolve it around the y-axis. So this time this is the area. Let me draw it, let me shade it with red here, and here we are going to revolve around here like this. So here I can also connect with y is equal to 4. So let me draw a line over there, and there is a reflection like this over here, and here are the disk that you're looking for. Again, I'm sorry about my drawing, it's not that accurate, but you can visualize it like this. So now let's start writing our integral, but first let's notice what is our radius over here. Our radius here will be the line from here to here, which is the r. I'm going to replace it with r. And what is this equal to? This is equal to x is equal to 2 over y, right? Since this is the line that is representing that. So here we can start by writing our integral. It is from 1 to 4, and it is going to be in dy. So here another way of thinking about r here, the radius, is whatever value of x here, which is x is equal to 2 over y, we are always landing on the line over here. So basically the radius is 2 over y. So here our equation is going to be pi, and r squared is our x is equal to 2y, so it's going to be 2 over y squared. So now let's just integrate this normally. The integration is not the problem here. The problem, or the question, mainly focuses on you graphing it and recognizing what is the volume and what is the area that you are trying to solve for here. So here I'm going to take pi outside, integration from 1 to 4, and this is going to become 4 over y squared dy, and you can take it up, so it becomes y2 negative 2 plus 1 over negative 1, and you are going to be left with is negative 4 over y from 4 to 1, and there's pi outside, and the final answer that you will get is going to be 3 pi. So now let's move on to our last question, which is a bit more challenging. It is we're given the line which is x is equal to y squared plus 1, and the line x is equal to 3 is revolved about x is equal to 3. So again, the first step is to draw this out. Let's do that. And here I want to remind you guys that y is equal to x squared is a parabola, which means it's a u, right, for the graph. And y is equal to negative x squared is going to be the opposite of that, which is a n, or inverted u, and x is equal to y squared is going to be c, and x is equal to negative y squared is going to be inverted c. So in our case we have this one and we have a plus 1, so we are going to start from plus 1 over here, which is 1 here, and we're going to do a c from here. So let me just erase these now. So keep that in mind, or you can just try substituting values and you will get the same. So now let's start by drawing the curve now. So here is the curve, and we also have x is equal to 3. So let me just mark that down, 2, and let's call this x is equal to 3. Let's draw a vertical line for that. And here is our graph, and now we know that the curve is revolving around x is equal to 3. So it is going to be like this, and we are going to revolve around the y-axis, I mean to say, in terms of dy. So the second thing that we notice is going to be this area, right? And we're going to revolve around the y-axis. So we need to find what is this point. Let me change the color so you guys can see this point and this point. So how do we do that? It is basically x is equal to 3. So if we go back to the equation, which is the original equation, it's going to be 3 is equal to y squared plus 1, and 4 is equal to y squared, or sorry, 2 is equal to y squared, and y is equal to plus minus radical 2. So this lower point is negative 2. So let me do that, negative radical 2, and this upper point will be positive radical 2. So now we know our limits. Now the next thing that we need to solve or find is the radius, and the radius is from the line x is equal to 3 to the curve, right? And this is from here also, and so on. Now how do we do that now? We know that the entire distance from here to here is 3. We know that the line, which is y squared plus 1, is this curve, and we want to find the radius, which is this part. Let me actually change the color over here. And the radius of course keeps changing. And we know the line, which here is y squared plus 1. So how do we find here this radius? Is simply going to be the entire thing minus y squared plus 1, right? Which we did right here, which is 3 minus y squared plus 1, which is the radius. So that's it. Then you simply put the formula, which is going to be integration, let me change the color. Integration from negative radical 2 from 2 to radical 2 pi r squared is 2 minus y squared dy, and the exact answer here is gonna be 18.96. I mean, you should know how to integrate this normally. Integration is not the main point here. So that's all for this video. I hope you enjoy and you understood this topic. If you have any questions, you can ask them in the comment section, and thanks for watching.